Cambridge AS Computer Science, Chapter 9, Algorithm Design and Problem Solving. This is the last part of this chapter. That part is really easy, is really useful, and it may earn you a lot of marks. Let us go to it, and it will be very simple, inshallah. There is something called the stepwise refinement. When we are programming a big project, we may split it down into smaller parts like this. Okay, actually, this is called a structure diagram or structure chart, but shows the splitting of a big program into smaller sub programs. So these are smaller sub programs or modules. Collectively, we may call these sub-programs modules. Okay, so this is the process of stepwise refinement. To make it easier to solve a big problem, we break the problem down into smaller steps. These might need breaking down further until the steps are small enough to solve easily. So, for example, you may break your program into smaller parts, and you may even further split some of them into smaller and smaller parts until they are easy enough to be programmed. Okay يا شباب؟ طيب. خلاص. يبقى this is what is called stepwise refinement. This leads you to modular programming. What is meant by modular programming is that splitting a big program into modules and then program each module separately. Okay, this is called modular programming. Okay, so one method of developing a solution is to decompose. Stepwise refinement is the other meaning of decomposition. Okay, so one method of developing a solution is to compose the problem into subtasks. Subtasks will be called modules. Each subtask can be considered as a module that is programmed separately. The rule for module identifiers are module names. Module identifiers are module names. Are the same as variables. So module names are like variable names. Okay, may not contain spaces. One benefit of using modular is that individual modules can be reused. Okay, so for example, you can write a module for one program and then use it in another program. Okay, one benefit of using modules is that individual modules can be used in other solutions. Okay, these therefore modules should be designed to be self-contained. Okay, I would like to have a module with all variables in it, local variables, because we will be talking soon about local variables. All these things must be practiced. Okay, however, now I will go to a very simple diagram that will earn you a lot of marks. Okay, these modules should be designed to be self-contained, which means all variables should be local inside of that module. This means they should not rely on external variables. External variables are global variables. You need these terms in your study. All variables are required by the module should be passed to it by using parameters. This is a very useful way of programming, is that you use functions and procedures. We will talk a lot about functions and procedures. Okay, it is very useful to know about these because in your programming you will be asked to write a function or write a procedure. A function or a procedure, both of them could be considered a module. Okay, so any of them is a part of a program. However, a function returns a value, a procedure do not have to return a value. We will look at these. We will be looking at parameter passing. This is what we will be studying today. Parameter passing. Okay? And we will talk about variables. So for example, if a variable is declared in this lower module, it is local to that lower module. And this is called the scope. The scope of the variable is limited to that lower module. However, if a variable is declared in the upper program, it is global to all other sub-programs. We will be practicing this. We will be practicing this, inshallah, and look at past papers. Okay? So a module could be a procedure or a function. Both of them are or is a part, both of them are parts of a program. Okay? However, a function returns a value. After calculating, it returns a value to the original program. A procedure do not return any value. Features of high-level programming languages that support the implementation of modular design, they have functions and procedures. Okay? They have the ability to pass parameters to modules like these. These are parameters getting up. These are parameters going down and values returning going up. We will be looking at that. Local and global variables. As we have said, local variable is inside that module only. A global variable is visible everywhere in your code. Okay, so this is a local variable. A local variable is a variable that is accessible only within the module in which it is declared. A local variable is used only within the module. On the opposite, global variable. A global variable is a variable that is accessible from all modules. A variable available to all modules is known as global variable. Okay? Let us look at modules. Modules are functions and procedures. Okay? Let us study a procedure. A procedure is a sequence of steps. Anything is a sequence, any code is a sequence of steps. A procedure is a sequence of steps that is given an identifier. It has a name and can be called to perform a subtask. So a procedure performs part of the tasks of a big program. Also a function. They are just exactly the same. However, a function returns a value. A procedure do not return a value. A procedure does not have to return a value. A procedure groups together a number of steps and give them a name. And we can use this identifier when we want to refer to this group of steps. When we want to perform the steps in a procedure, we call the procedure by its name. This is an example of a procedure with parameters. This is a procedure with parameters. Let me show how it is written, and you may also like to practice it using Python. Okay, so this is a procedure. When you write it in pseudocode, you write procedure. Okay, and the name of the procedure, for example, print start. And it takes an argument. When you call it, it should receive a value for a parameter called number. And that number will be integer. Okay? Okay. Okay. And then declare counter. This is a local variable. This counter is declared inside the procedure print stars, and it is a local variable to the procedure print stars. Okay? And then for counter equal 1 to number, then when you call it, for example, with 7, it prints 7 stars. For counter equal 1 to number, for example, if you call it with 7, okay, and then for counter equal 1 to 7, output start next counter and end the procedure. Okay, so this is the procedure, part of a program, not a whole program. And when you want to call it, you write call print stars. Print stars will call that print stars. And the 7 here goes into the parameter number here. So it will run and printing 7 stars. You may call it with any other number, and then it responds appropriately, printing the required number of stars. So this is a procedure. And as you can see, it doesn't return a value. What is the meaning of returning a value? Here in the function, we will see how a function will return a value. Here, we will see how a function will return a value. If you like to play with it using Python, I recommend, because maybe some of you will be doing A-level. Let us play with it using Python. Okay, so this is PyCharm. Okay, okay, let us get rid of that code. And for example, let us copy and paste this. Def print stars. Okay, so in Python, a function or a procedure starts with the keyword def. Okay, however, if you run it, nothing will happen. You know why? Because there isn't a calling statement. Let us put a calling statement. This is the calling statement. It calls the procedure by its name. Okay, now when we run, see, we have 7 stars. We may call it several times. And this is the beauty of using functions and procedures. So you call it another time with 20 stars. So when you run, this is the first call, this is the second call. Okay? And this is a procedure that takes parameters. This is the number is the parameter. And the 20 goes into that number. Okay? Now let us, and this is how you call a procedure in flowcharts, using a flowchart. Next, let us study about a function. Let us study about a function. A function is exactly like a procedure, however, it returns a value. Let us look at this. So a function is a sequence of steps that is given an identifier. A function or a procedure collectively called module. Okay, and there are many benefits of using modular programming. Okay, so for example, a function is exactly like the procedure, however, it returns a value. So see, this is return. Let us study this function in pseudocode. A function starts with the keyword function, and this is the name of the function, and this is the arguments or the parameters. This function is very simple. It accepts a distance in inches, multiplies that distance by 2.4, and returns the equivalent distance in centimeters. Very simple. So see, it returns a value. It returns a value. And all of this is copied from the O-level syllabus. It returns a value. Let us see. So whenever, for example, you call convert to centimeter with argument 10, that 10 goes into here. So it accepts a real number. And after it works, it returns a real number because it will return centimeter, and that centimeter will also be a real number. Declare cm as real. This is a local variable. cm is inches multiplied by 2.5. Inches is a parameter. Is a parameter that receives its value from the calling. Okay, and it multiplies inches by 2.4 and assigns it to the variable called centimeter, and then returns centimeter back. Here is the value in centimeter. It goes into a variable called my distance, and then output my distance. This is a function exactly like a procedure. However, it returns a value. Let's play with it. Let's play with it using Python. Okay, let's go here and get rid of everything. You have to notice one thing. Using Python, if you are using a function or a procedure, both of them start with the keyword def. However, in pseudocode, if you are creating a function, you have to write here function and the function. If you are creating a procedure, you have to write here procedure and the procedure. In Python, it doesn't care. However, in a function in Python, at the end, there would be return something. So here you have return, so it is considered to be a function because a function returns a value. Okay, let us give it a call. Let us call it. Because right now, if you run this, it will not work because it is missing the calling. Let us now, you call convert to centimeter with an argument 10.05, 10.5. And then it goes into here, the 10.5 goes into inches. Inches is multiplied by 2.4 and stored in cm. Return cm. Because a function returns a value, you should accept that value and store it in a variable. And later on, you may print that variable. For example, so here it is printing 25.2. If you here you put, for example, 30, you run it again. Whatever you put here is multiplied by 2.4 and then displayed. Okay, shabab, this is a function. Both of them are called modules. Okay, what are the benefits of using modules? Program code is easier to implement because you are splitting it into smaller parts and you may be programming smaller parts separately. Easier to program the solution for a complex task when it is complex. Easier to debug. What is meant by debugging? Finding and fixing errors. Maintain, repair, as each module has to be can be tested separately. Tasks may be shared. You may give each programmer a module to work on it independently and only tell him about parameters going and return the values. Tasks may be shared among a team of programmers, as some modules could be developed in parallel by teams with different expertise, with different skills. Modules be given to program specialists. You may give a module to a programmer who is a specialist in that topic. Encourages the reusability of code. You may use the code in another program or call it from another program. Okay, I hope this is clear. Now we come to the most important part, that is structure chart. Those charts show relationships between modules, and you have to draw plenty of them and those arrows, and then you can earn a lot of marks. And this will help you about understanding modules. Okay? Okay. Structure chart is a graphical representation of the modular structure of a solution. So if you have your solution is divided into functions and procedures, a function return a value, a procedure do not have to return a value. I keep saying this forever, okay, to show the interrelationships between the module. Each box of the structure represents a module, okay, represents a module. This is the chart, this is a module, this is a module, this is a module, and this is the main program. A structure chart also shows the interface. What is meant by the interface? Data in transit between modules. Data getting down and going up between modules. Okay? So, because if you want to give these to programmers, just tell him about the interface. What data is expected to be returned and what data is expected to be given. Okay? So, the structure chart also shows the interface between modules. The variables. These variables are referred to as parameters. These are parameters. Parameters are, okay? A parameter is a value passed between module. A parameter supplying a value to a lower module is down arrowed pointing arrow, downwards pointing arrow. A parameter supplying a new value to the module at a higher level is shown as an upward pointing arrow. So this is downward pointing, getting data from the main program into the module. This arrow going up is the return data. Okay? Information that a structure chart can convey. There are so many pieces of information you can put here. It shows the hierarchy of a module. How a hierarchy of module. It shows the hierarchy of modules. How modules are layered above each other, like this. Parameters that are passed between modules. Data getting down and going up. Sequence. So probably you do this module, then that module, then that module, from left to right. Or maybe there is a selection. This is called a selection. Or maybe there is a repetition, because we have studied if then else and case, both they represent selection. We have studied for, while, repeat, until, and the three of them represent repetition or iteration. So this is also drawn on the diagram. The sequence, selection, and iteration. Okay, let us look at these examples bit by bit and refer to classified, because probably all of them are copied, or most of them are copied from the classified. Let us study this first, and then we go to the classified. Example, a structure chart of a module that calculates the average of two numbers. So this is the parent module that calculates the average of two numbers. The top level box, this is the top level box, is the name of the module, which is refined into three subtasks. This will be split into three subtasks. So the module called the average will be refined into three subtasks of level 1. Okay? Okay, let us look at this. First, the program will call this module input numbers. It will accept two numbers from the user and pass them back to the main program or the main module called average. So here, when it runs, it will ask the user to input two numbers, and these two, number 1 and number 2, they are returned back to the original program. Okay? And then the original program will call the calculate average module, passing to it number 1 and number 2 taken from here, and returning the average. After the average is calculated, it is returned upward again to the main program. And then the average is passed to that last module, that is output average, to display it on the screen. Okay, Shabab? Okay, so this is a diagram. I hope you can understand it. Please go to your classified page 84. A structure chart is a tool used in modular program design. State 3 pieces of information that a structure chart can convey about a program design. What can you tell? What can you tell from a chart like this? What are the pieces of information that you can get from a chart like this? It shows the hierarchy of modules. 3 pieces of information a structure chart can convey about the program design: the hierarchy of modules, parameters that are passed between modules, the interface between the modules, sequence, iteration, or selection. As written in my notes, information that a structure chart can convey about a program design: it conveys the hierarchy of modules, parameters that are passed between modules, this is called the interface between the modules, the sequence, module selection, module iteration. The following diagram shows part of a structure chart. Check out. Okay? With 2 pieces of information getting down and 1 piece of information getting up. Example of the data items that represent the arrow are given. A is 234, 4.56. This is a real number. Maybe this is the price of the item. And another, so information A is this. Information B is Mr. Robert whatever. Maybe this is the name. This is the name of the customer. And the return is true. Please notice that the circle here is solid. Anything with a solid circle is Boolean, true or false. Okay? So this is a function because it returns a value. This is a function that returns a value. And that return is that true or false. And then it accepts 2 parameters. The module called the card payment. So the question is asking you to write the pseudocode, to use pseudocode to write the function header of the card payment module. So what would be the name of this function? For example, call it card payment. Right here, function, because it is a function. And its name is card payment. And its name is card payment. It accepts 2 arguments, 2 parameters, A and B. One of them is price, and this is real. The other one is name, and that is string. So you write here parameter A, that is real, parameter B, that is string. And because it is a function, it returns something. It returns upward that arrow that's going to be true or false. Maybe it returns Boolean. It returns Boolean. So you have to write it like this. Okay, ya shabab? Okay, so this is the answer please copy it. I hope it is clear. So see, that kind of question is very easy to achieve. Let us study few other example. This is example structure chart, that can also show control information. Structure charts can also show control information. What are these control information? That rhombus here represents selection. So this diamond, guess equal number, yes or no? If guess equal number, yes, you output congratulations. Otherwise, you don't output, you output the other one. So this is an example of selection. This is a control structure that shows you may call this or that. Okay? So structure chart can also show control information. Selection, this is selection. Repetition, this is repetition. Select, search item, add to basket. Search item, add to basket. So these two modules are being called repeatedly. This is an example of selection. This is an example of selection. This is an example of, this is an example of repetition. This is an example of repetition. This is an example of selection. Okay? Okay, so you may also show sequence that one after the other, and also you may show selection or repetition. This is selection, a diamond or a rhombus. This is iteration or repetition. A simple number guessing game would be modularized and presented as a structure chart. So this is the main program. It called generate secret number, and it returns a secret number. And this input a guess, and it returns input a guess. And then you forward the guess and the secret number to that output message, depending whether or not the guess and the secret number are equal. If they are equal, you get congratulations. If they are not, you get consolation method. So this is selection, and these are parameters. Okay, another example. Okay, customer can search for items before adding them to a virtual basket. So this is online shopping. Customers can search for items before adding them to a virtual basket. When they have finished shopping, they pay for the item. So this is a checkout. So first, they search for item and add, and then check out. Either, see, this is diamond, either pay by card or pay by account payment. You pay by one of these two methods. This is selection. The program provides output for the dispatch. This is the dispatch. Some of items. Some of the key features of the systems are as follows. Customers can add many items to the shopping basket. That's why you have a circle here. A customer can add many items to the shopping basket, so you can see a cycle here. So this is repetition. Payment may be either means selection, either by credit or debit card or by adding to a customer account. So this diamond shows selection. The shop may dispatch the item in one or more packages. So see, here you have a loop that represents repetition. Okay, so in that question, you were asked to draw a loop here, a diamond here, and a loop here. The section of the chart is shown below. The section of the chart is, okay, the section of the above chart, a section of the above chart is shown below. Maybe this is the checkout. Okay, يبقى a section of the above chart is shown below. It is to show the parameters pass between the checkout, this is the checkout, and the car payment. So what data is getting down and what data is getting out? Number A is card details, for example. Number B is cost details. And these may be switched. A and B may be switched together. And C, anything with a solid circle is Boolean. C is a flag indicator for successful payment or payment confirmation. Okay? So that was the answer. They are asking you, what does A, B, C represent? Okay? Okay, another question. Let's go through all of these and then we go to past papers. Okay? A structure chart shows part of the design of a program for an online shopping system. The user has already added a number of products to their shopping basket. Okay? Draw on the chart the symbol to show that the process of modifying the basket may be iterated. Okay, draw here a circle. Okay, so the question asks you to draw on the chart the symbol to show the process of modifying the basket contents. This is modify basket content. May be iterated. Please put a circle here with an arrow. Something like this. Please draw this. This is the symbol that shows iteration. Okay. And you are asked to fill this table. You are asked to fill this table. Okay. So, modify basket content. Modify basket content. What is A? A would be the product ID. Input product ID. So A is the product ID. And then what is B? B is again the product ID. And what is C? C is a flag value indicating operation successful or failed. So you input here the product ID, and then the product ID goes down into remove product, and anything with a solid circle like this is about true or false. And then what here? Change a product. Number D is another product ID, and number E is the quantity, and number F is a confirmation of the successful changing of product and quantity. Okay, so in your question you had to fill these. Okay, another example. See how many examples do we have? Only 2 examples are left. The structure chart shows part of the design of a program for an online shopping basket, online shopping system. This is process basket. Draw on the chart to show the following facts. Each of the modules at the lower level return a Boolean parameter X. So here X going up with a solid circle, here X going up with a solid circle, here X going up with a solid circle. Process basket will call only one of the module at the lower level. Put here a diamond. Put here a diamond. The process basket will call only one of the modules at the lower level. Put here a diamond or a rhombus to show the symbol of selection. Parameter A to G shown on the chart will be used to pass the following information. Payment detail. Which one of these will be payment detail? Maybe something here. Maybe E, F, G would be payment detail. Quantity. Maybe E or G. Maybe here the quantity. Basket ID. Delivery address. Maybe also here delivery address. Item ID. The following table shows the parameters and information it represents. Number A is the basket ID. Discard basket, remove all item. So A will be the basket ID. Okay? And basket ID, item ID, quantity with anything B, C, D. Here, basket ID, quantity, basket ID, item ID, and quantity. Change item or quantity. And here, E, F, G, basket ID, delivery address, payment detail in any order. Okay? The last thing, and I will go to classify. Deriving pseudocode from a structure chart. Deriving pseudocode from a structure chart. 6 program modules. These 1, 2, 3, 4, 5, 6. 6 program modules implement part of an online shopping program. The following table gives the modules and a brief description of each module. Shop, allow the user to choose a delivery slot. So I think shop will call choose a slot. Select item. Select items. Maybe gonna be fill basket. Add and search. So select item, search and add. So call slot to choose a slot. Select item, it will call search. Add, it will call add. Choose a slot, allow the user to select a delivery time, return a delivery slot number. Fill basket, allow the user to fill item, add to the basket. So fill item will call add. Maybe select item will call fill basket. Checkout completes the order by allowing the user to pay for the items, return a Boolean value to indicate whether or not payment was successful. Search, allow the user to search for a specific item, return item search, add item to the basket, take an item reference and a quantity as parameter. From this, you are supposed to draw that. The online shopping program has been split into subtasks. As part of the design process, the structure chart for the sixth module is described. So shop, it looks like shop is the parent. And shop calls, choose a slot, slot returns a slot number. Returns, whenever here a return, put an arrow back. And then fill basket, it calls fill basket. And the fill basket will repeatedly call search and add, search and add. The fill basket will repeatedly call search and add. The search will get the item ref, and the add will take the item ref and the quantity. So search will return upward the item ref. Search, allow the user, returns an item reference. So goes up the item reference. And add an item, take an item reference and a quantity. So item here, item ref and quantity. And then the last one is the checkout, completes the order by allowing the user to pay for the item, returns a Boolean value. So this is a solid to indicate whether or not payment was successful. The only thing to say is that search and add is a repeated process. So you put here a circle like this, iteration. Okay? Okay. That's the end of it. That's the end of it. Let us go and practice using classified. Please go into the classified, into this. I think we did that. We did that in the notes. Please do it again. Please give yourself time and do it again. Please. Draw on the chart to show the following. Each of the modules at the lower level, these return a Boolean parameter X. The Boolean parameters have shaded circles. So here you need to draw something like this. This is a Boolean parameter X with shaded circle. This is another Boolean parameter X with shaded circle. This is another Boolean parameter X with shaded circle. So it matters only shaded when they are Boolean. So each of the modules at the lower level returns a Boolean, so make it shaded like this. What else? The process basket will call only one of the modules. So it is a selection. So draw this. So these are the two answers. These are worth 2 marks. Put a rhombus here and put solid shaped arrows going up here. And these are the answers of the first question. Second question, parameters A to G will be used to pass the following information. Payment detail, quantity, basket ID, delivery address, item. Please put them here. A will be what? A will be the basket ID. A will be the basket ID that will be discarded. B will be what? Okay, take your time and I show you the mark scheme. You have to figure out. You figure out. The structure chart shows part of the design of a program for an online shopping system. Discard the basket details. So I think A will be basket ID. Right here, basket ID. Let us check. Yes, it is basket ID. Okay, so we are done with that. Here, change item quantity. So you send down the item ID. You send down the basket ID. You send down the new quantity. Okay, so BCD would be basket ID, item ID, new quantity in any order. BCD would be basket ID, item ID, quantity in any order. Okay, then here, 3 things going, check out and pay. What left? Delivery address. Here should go the delivery address. Payment detail. Here should go the payment detail. And maybe the basket ID. Here should go the basket ID. So, basket ID, delivery address, payment address in any order. Just play with this information going down and this information going up to earn marks and to learn about parameters passing, because we will need this in our study in programming. If this is clear, go ahead to the next one. How many do we have left? Yeah, this one, that last one was the one we already drew. Okay, I will stop now, and I think you can go through the rest of the questions here and check your answers using the mark scheme. Okay, so these are easy marks you may get. Okay, please do all these. Good luck for you in your study, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. This is the end of chapter 9.